A segment has an endpoint at -5, 2 and a midpoint at -2, 0. In what quadrant does the other endpoint lie? So you would probably want to start off with a coordinate plane. You're going to plot these to the best of your ability. 1, 2, 3, 4, 5, 1, 2. It's not going to be perfect. -2, 0. Here's your reminder of the quadrants. From algebra. Today's an algebra review day, so we thought we'd throw some quadrants in. So the key to this warm-up is knowing that you were given an endpoint and a midpoint. So what are you looking for? We're looking for the other endpoint. And we just want to know what quadrant it lies in. Now, if you just look at how I plotted those, if my graph is to scale, which it's not perfect, it's looking like it's probably going to fall in the 4th quadrant, right? Why would it not fall in the 3rd quadrant? Well, probably because a midpoint is equidistant from the endpoints. And if I throw a point right there, that doesn't look equidistant from, I'll call this point M. This point does not look equidistant from M as the original point. And so also a midpoint can't end up over here. A midpoint by definition has to lie on the segment, and that one would not lie on the segment. Now, we're done guessing. We're done just looking at this. How would we actually find the other endpoint? What do we need to use from yesterday? Leapfrog. Very good. So we need to actually use leapfrog to find, our endpoint. Now, the only way that you can, well, one of the ways you can mess up leapfrog is by not putting the midpoint in the middle. That's a 5. Make sure you put the midpoint in the middle, put the midpoint in the middle, put the midpoint in the middle. All right, let's play leapfrog. -5 plus 3, so we're going to go plus 3 again. We're going to end up at 1. And then from 2 to 0, that's -2. So we're going to go -2 again. We're going to end up at 1, -2. And hopefully that's collinear with my other 2. Yay, kind of. So I could connect the dots and I could put tick marks to show that that point really is in the middle. So that's the warm-up. It was playing leapfrog. Here is answers to your homework. If you notice, you've already done the distance ones before. We stole the distance ones and put it on the distance homework. So you've already done like 1 through 3. You've already done 12, probably 11. So really the only ones you need to focus on were the midpoint and endpoint ones. Okay? So check over your answers and let me know which ones you would like me to work. Number 3. We've got 12, 6 and -8, 18. This is really just a review from last unit. This is just a review. It said to find the distance to the nearest tenth. So we're just going to do our good old distance formula. This is subtract, subtract, add, squared, squared, because it's really just Pythagorean theorem. We're going to throw our x's in one parenthesis and our y's in another parenthesis. You don't even have to show work on this. I don't require you to show work. You can go straight to your calculator and you can do square root of, parenthesis open, 12 minus -8 squared, parentheses closed before you square it, plus 6 minus 18 squared, and you get 23.3238, and it says to round to the nearest tenth. The nearest tenth would be this point right here. You ask your neighbor, do I stay a 3 or do I bump up? And your neighbor says, stay a 3. So 23.3. Okay, next one I was asked about was number 4. Find the distance between the stations. So to find the distance between station A and B, you probably should have just drawn a right triangle. You've got A, you've got B. And so this is also not from yesterday's lesson. This is old news. What is our delta y? 1, 2, 3, 4, 5. Sorry, I don't have this up here with me. This is A and B. Delta x is 1, 2, 3, 4. And so we're just doing Pythagorean theorem 4 squared plus 5 squared, and we take the square root. You don't have to show any other work than that. And I'm getting 6.4 as the distance from A to B. Now it wants to know the distance from station B and C, where station C is located at 5, 8. So I'm not going to do the distance formula again, but that's also another distance formula. So I am going to skip number 5 because I've done the distance formula already. All right, number 11. So I'm just realizing y'all asked me no midpoint or endpoint problems at all. You only asked me distance problems. So hopefully you're good on the midpoint and the endpoints. I'll plot these just for fun, but you don't really need to plot them. 4, -1, that's A. And -2, 3, that's B. M is the midpoint. What is the length of MB? So you've got two options. You could find the midpoint, step 1. Then you could find the distance from M to B. Or you could find the distance from A to B and divide it by 2. And to me, that one is less steps. That one is less work. So I'm going to find the distance from A to B, and I'm going to half it. Because I know MB equals half of AB, where M falls somewhere in here. I'm not exactly sure where. So once again, I am doing the distance formula, which we know and love. The more you practice it, the better you get at it. I'm going to put my x's in one parenthesis and my y's in the other. And then you get your answer and you divide by 2. And I'm not going to keep going on that. At the top of your notes, or you could write it on a different sheet of paper, this is your login. This is your login to the textbook. Now, the teachers haven't even been trained on the new